Okay, today we talked a little bit about turbulent flow versus laminar flow. And the distinction between these two lies in the nature of the flow, and the easiest one to visualize is flow in a closed conduit like this. So we have two flows. In laminar flow, so I want to try to show this, if we inject some dye into the flow, it forms layers that are that remain aligned with the direction of the flow. So here we have our flow direction. These are little arrows. And I've injected a red, blue, and a green dye into the flow. And they form these stripes that are then unchanged and align with the axis of the pipe. In turbulent flow, so over here we have turbulent flow. Turbulent flow, if we did the same thing, those stripes of dye would intermingle and mix throughout the flow. And so there's our red line, our blue line is would mix in some way, and then finally the green line again would start from some location and then mix, and you'd have these three lines completely mixed. Now on average you can still think of what the velocity is at any location. In laminar flow, the velocity profile is well defined and each layer has its own velocity. In turbulent flow, you need to think about it in an averaged sense, and if you did, you could define a profile which is similar to the laminar flow profile, a little bit flatter in the middle, a little bit sharper gradients on the edges. Not the best sketch here. This is the mean velocity, or a flow could be steady in the mean is the way the text uses it. But the mean velocity here is the one that's averaged sufficiently to take the turbulence out of it. Now, what defines the transition between laminar and turbulent flow? This is what Reynolds' original experiment in the 1800s looked at, and what he found was that the transition was a function of the velocity in the flow, the diameter of the pipe, the fluid density, and the fluid viscosity. Combining these, we get the Reynolds number, RE. And the Reynolds number has the form rho times velocity times pipe diameter divided by the viscosity. This idea of a dimensionless quantity that describes the transition is something we'll explore next in our next lecture. For now, we can say if RE is greater than about 3,000, then we have turbulent flow. If RE is less than about 2,000, then we have laminar flow. And in between, it's called transitional. So next week, we'll talk about dimensionless groups, and then after spring break, we'll take that up more completely.